Assalamualaikum, my name is Muhammad Hakimi bin Muhammad Sabri and my number matric is 270242. Okay, today video I will answer the question 1 for individual assignment in semester A 201. Okay, this given the function x to the power of 5 minus 8x to the power of 3. So the question is find the x-intercept or intercept, the interval where the function is increasing and decreasing, the x-coordinate of inflection point, upper interval where the function is concave up and down, local minima and maxima, and using all this information we must to sketch the graph of function. Alright, now we want to find the x-intercept. Okay, x-intercept is when fx equal to 0. So the function equal to 0, and we find it x equal to 0 and x equal to plus minus 2 square root of 2. So in term of point 0, 0, 2 square root of 2, 0, negative 2 square root of 2, 0, and that's all. Okay, now we want to find the y-intercept. Y-intercept we can find is when x equal to 0. So we put the value of x is 0 and we find it the y-intercept at 0, at the number of 0. So the y-intercept is 0, 0. Okay, now we find the critical points. The critical points, we must use the first derivatives of the function. So the first derivative of function is 5x to the power of 4 minus 24x to the power of 2 minus, equal to 0. Okay, now we find the value of x with the function of the first derivative, and we find it x equal to 0 and x equal to plus minus 2 square root of 30 over 5, and the critical number is this. Okay, and the critical point is 0, 0, 2 square root of 30 over 5 minus negative 33.65 and negative 2 square root of 30 over 5, 33.65. Okay, now we want to find the interval of increasing and decreasing. Okay, okay, from the critical point we find that there's a four place which the interval is increasing or decreasing. Okay, by use the first derivative of the function. Okay, we put the value of negative 3, negative square root of 30 over 5, square root of 30 over 5, and 3. So the reason we put this point, this number, to we identify the signs, the sign whether is positive or negative. If it's positive, so the interval is increasing. If negative, the interval is decreasing. So we find that the first point is increasing, decreasing, decreasing, and increasing. Okay, now we find that the interval of increasing is at this point and the interval of decreasing at this point. Okay, now we want to find the inflection point. Okay, the inflection point, we must use the second derivative of the function. So the second derivative of function is 20x to the power of 3 minus 48x equal to 0. Okay, now we want to find the value of 0, the value of x. So x equal to 0 and x equal to plus minus 2 square root of 15 over 5. And this is in term of point 0, 0, minus 2 to square root of 15 over 5, 20.82, and 2 square root of 15 over 5, negative 20.82. Okay, now we want to find whether if it's concave upward or concave downwards. Alright, so we find that there has a 4 place where the slope is changing. Okay, so we put this value to find the sign whether if negative or positive at the second derivative of function. Okay, so the first place is concave downwards because the sign is negative, and the second place is concave upward because the sign is positive, and the third place is concave downward because the sign is negative, and the third one is concave upward because the sign is positive. After that, we can easily sketch the graph. Okay, and then we can sketch the graph. So this the visual with the graph. Okay, so we know the x-intercept is at here, and at here. Okay, so this place is as the x-intercept, and this place is y-intercept also. Okay, the critical point is at here, remember, and at here. So the local maxima is at here, and the local minima is at here. Alright, so the inflection point is at here, and at here. This is the inflection point. Okay, so this is concave outward, and the second slope is concave downward. The third point is concave downwards. Sorry, the second is concave upwards, the third is concave downwards, and the last is concave upwards. Okay, that's all for me. Thank you.